Hello everyone, we are Team Smooth Operator and this is our hackathon project threatops.ai. So basically what we have built is an monitoring platform which monitors the health of each and every client, each and every server that we are protecting, or each and every IoT device that we are protecting, right? So for instance, a user or a person that avails our services basically connects with our global dashboard through a connecting service like this, right? And he basically he posts all the data of his system, the memory usage, the RAM usage, the CPU usage, and all the packets that he is receiving or not. And so this is a live data. So it is fetched. This graph of CPU and RAM usage is fetched from my MacBook Air, right? We can see everything is fetched, right? Now this is a monitoring system, right? If any attack is being performed on our system, on our client, it would be showed up here, right? So let's go and let's do a demo attack, right? So let's do a SQL injection with 100 request count and 10 concurrency threads, right? So let's see, the attack has started, right? So here we can see that the attack is being shown, right? So what we can see is our ML engine has guessed, right, that it is a malicious SQL script that has been run with a confidence of 99%, right? So these are our homegrown models, that ML models that predict the predict what type of attack it is, detect it and blocks it, right? Apart from that, to enhance the performance, we have also in the client side we also do a basic regex check, that if it is unencrypted, right, and if it is SQL attack, let's say, so 1 equal to 1, right, those kind of scripts would be pushing. So we would detect as many simple packets of SQL attack as we can from regex, and we would already deny them, right? And for those whose cases are a little bit tidy, we send to the model, right? So here we can see these are the IoT models, right? So basically under this healthcare, my MacBook currently is hosting the healthcare server, right? So we can see a pacemaker IoT device, MRI scanner, right? So all this can be monitored, and to block, what we can see, we can take actions against it, right? And basic actions are, first of all, you would rate limit the IPs, right? So the IPs from which this attack was made was 10.135.48.149. So it is rate limited. If it increases, it can also be blocked. The IP can be blocked. All the requests from that can be blocked, right? And apart from that, we can also separate them or isolate them, right? Then we can have all the other options, that control options that we can from here. We can also give alert to the user from here, and all the type of monitoring we can do. And we can see all our client. Currently there is only one client, but we can monitor health of each and every client. We can protect their end-to-end IoT devices, as well as we can protect their server levels and so on.
Models. We have 5 different models. The first model is the web brain model, in which it is a random forest classifier that stops the SQL injection and XSS attacks using TF-IDF character analysis. After that, we have healthcare model. The healthcare model, it is a two-layer LSTM defending Internet of Medical Things networks from DDoS attacks. It analyzes 20 timestamp sequences of network traffic, and it protects from the various DDoS attacks. After that, we have the urban model. The urban model, it is an LSTM forecasting, predicting traffic flow 1 minute ahead. By learning the patterns from 10 minutes windows, it is not only optimizing the smart city traffic but also detects the sensor manipulation through prediction anomalies. The final model is our network shield model. The network shield model, it is a three-layer deep neural network that is trained on 33 attack types from the CIC IoT 2023 dataset. It processes 78 network features. It provides comprehensive protection for any IoT infrastructures.
The high level design of the entire project. So basically, we have this backend services, and we are scaling the backend services on Kubernetes with Docker. So this is the API gateway, and these are the services that are protected. So there is a subnet that has been created between these services so that they can communicate with each other. What this does is ensures that nobody can contact any of the services from outside, but can contact them through the API gateway. So now we are going to have a look at the Kubernetes engine. So this is our Kubernetes engine, and I'm going to quickly put in a token so that you can see it. And these are the services that we already have launched. So here you can see that Alert Manager, which is one of our services, is having two instances, means there are two pods of this particular instance. So this is how we are scaling them, and also we are using horizontal pod scaling, which is an automatic scaling. And what happens in that is that if the traffic increases, then automatically new pods are created, and this helps to handle the traffic and ensure that the system does not fail.